Hello, I'm going to be demonstrating and going through my code. Um, I organized my code into six separate classes. I'm going to go into depth on one of the classes and then point out the differences in the other classes. To accomplish my task, I had created a simple node class which holds the state as an integer array, some other variables. I also created a queue class which has a queueNode class which holds a node and then points to the next node. Uh, my queue class also holds the time, first and last queue nodes. Um, to add to the queue in the breadth first search, I add the queue to the back of the list. The difference is right here. Um, this is my dequeue function, just pops the first node off the list and sets the first to first.next and returns the node. Get size over there. This is my main function, simple graphical user interface to get the difficulty. Uh, this is the main loop. So all I do is while there is something in the queue, I call the solve function on it. The solve function is here. First, I get the state as an integer, which is just easier to check if it has been visited and if it is the right answer, then iterating through the array. I put the state in the nice, neat formatting. I check if the state is the solution. If it is, then I don't do anything else to it. If it is not the solution, I check if it is been visited. If it has not been visited, I add it to the list, to the array list, and I uh, call my function to put the children into the queue. The function to put the children into the queue is here. I find the position of 0 and I make all of the appropriate moves depending on the position of 0. By calling all of the move left, right, down, up functions, which are all here, I create a new child node here, and then in this line I swap the uh, correct numbers, moved right, left, up, down, and then this is my simple swap function, and then the print state function that I referenced before. The difference between the next couple, this function's different because it adds the node to the back of the list, or to the front of the list, uh, which is the depth first search part of it. Uniform cost algorithm sorts when I add it into the queue, it sorts the queue, so it iterates through the linked list until the total cost is in the appropriate position to add the new node. The greedy best first algorithm, I do something similar to uniform cost where I iterate through the list and then, uh, but this time by the cost, uh, not the total cost. Uh, this is my A star in the correct place. In this function, uh, I hold the number of misplaced in a variable that is found by this function here, and then I sort the uh, new list by uh, the number of misplaced, and the similar idea for the Manhattan, which is here. An example of my code running. For example, the A star search for the medium difficulty solves it. Uh, Another example would be yeah, sure, the greedy best first search for the medium difficulty. That might not have been the best idea, but yes. Thank you.